Hi, in today's video, we'll have a look at one of the most fundamental concepts of all of statistics, and that's the difference between correlation and causation. So the fact that two variables are correlated does not imply that one causes the other. So that's probably something that you've heard being said before, but it's really, really crucial to understand how easy it is to make that mistake. Now, there are situations where um, a pattern could exist between two variables that would be entirely spurious. So there's an entire website that is dedicated to that. So if you go to tylerweigen.com, you will see a series of plots that show that two different variables actually follow almost the same pattern over time. So, for example, here, the worldwide non-commercial space launches is extremely highly correlated with sociology doctorates awarded in the US. And as we can see, so this goes from 97 to 2009, we can see that when the number of non-commercial space launches goes down, the same is true for sociology doctorates awarded. And when it goes up, then you see the same pattern for sociology doctorates awarded. So it could give the impression that those two variables are related. Now, obviously, in this kind of case where we have two variables where we do not see any reason why they would be related to one another, it's quite easy to say that this relationship is spurious. But there are plenty of cases where that might not be the case. And you need to be especially cautious when you're dealing with time series data. Okay, time series data very often have trends. And whenever you have trending variables, it's extremely easy to see that they're correlated. Okay, and with time series data, most variables actually will have some form of trend. So you will see that one variable is related to another. So, for example, you'll see that over time, fertility rates have gone down in Western Europe, and the population of storks has also gone down. And for instance, you could say, well, there's a correlation between those two, so maybe there would be a causal relationship between them. And obviously, there's no real reason to assume that there would be a causal relationship between those two variables, but the data might show similar downward trends. Okay, and you can take any sort of time series data and you will come across these kinds of problems. So you have to be extremely cautious whenever you deal with time series data. But also with any other type of data, you will have this problem of a correlation not necessarily implying a causal relationship between two variables. And I want to give you a very clear case where that happened, and that's based on a study that was actually published in a scientific journal called Nature. So one reason why you could have a pattern between two variables is that there's another variable which affects both X and Y. So in 1999, a study in Nature showed that young children who sleep with the light on are much more likely to develop myopia in later life. And what they argued was that sleeping with the light on causes myopia. Now, this, on the face of it, seems relatively plausible. Okay, maybe that the lights then the children will look at would damage the eyes, and that would be a reason why they develop myopia later in life. A later study actually showed that parental myopia is linked with the development of child myopia, and myopic parents are also more likely to leave the light on in their children's bedroom. So here, what we can see is that the correlation that the first paper identified and assumed was a causal relationship between two variables was actually caused by another variable that affected both X and Y. Okay, and that's a type of pattern that you always need to keep in mind whenever you see a story that seems plausible or logical. Always think about whether there are other variables that actually could be causing both X and Y's. And there are different kinds of setups that could cause a problem when looking at correlation and assuming that this would be the sign that there's a causal relationship between two variables. Okay, so it's super, super important to be very, very cautious, never to assume that a relationship is causal without having some proof that it's actually a causal relationship and not just a correlational relationship. So, and I want to finish on this cartoon from XKCD because I think it really says something quite profound about how easy it is to make that mistake. So in the first drawing, you see that the guy says, I used to think correlation implied causation. Then I took a statistics class and now I don't. And the other person says, sounds like the class helped. To which the man replies, well, maybe. And this shows that, you know, how easy it is to make that mistake, because when the woman says, sounds like the class helped, that's everyone's reaction, okay, when we see this, because it seems quite logical that he didn't understand this principle that correlation does not imply causation. Then he took a statistics class, which should have helped. And so it seems plausible to think that there's a causal pattern between the two. But there could actually be something else that led him to realize that correlation did not imply causation. So always be skeptical whenever you see a pattern that you think is causal. Ask yourself, is it really the case? Do I have enough proof to say that it's causal, or is it just a correlation? So that's it for today's video, and I'll see you in the next one.